Welcome to Performance Around the Clock, where we explore the latest research on how to keep our body and mind at our peak physical, emotional, and intellectual performance around the clock. I am your host, Professor Satchin Panda at the Salk Institute, La Jolla, California. On this podcast, we'll talk to leading scientists, clinicians, coaches, and policymakers about human performance. We'll cover different topics, including how different organs and different parts of the brain contribute to human performance. And we'll also learn how our lifestyle, that is, what, when, and how much we eat, sleep, and move around every single day, affect our health and wellness. I hope you'll join me in this journey to explore new knowledge and adapt it in our own life to improve our health and wellness throughout our life. Welcome. Today, actually, I'm in Copenhagen and I'm really lucky to have Professor Frank Scheer from Harvard Medical School. He's the leading expert on human circadian rhythms and sleep. And welcome, Frank. I also understand that you have different affiliations and you wear different hats. So, is there anything else I missed?
Well, thank you, Sachin, for having me. It's great that you're organizing this. So congratulations on this effort. So I'm a professor of medicine at Harvard Medical School, and I'm the director of the medical chronobiology program at Brigham and Women's Hospital.
Yeah. So actually, this is one of very few chronobiology or circadian biology program entirely focused on humans. And I think in the entire world, there may be only 3 or 4 such centers like yours.
There are not that many centers that have the facilities to study the human circadian system in this to this degree. So yeah, a handful, I would say.
Yeah, I mean, for those of you who don't know, human circadian research is very complicated, very time consuming, and you need specialized, you can say, apartments where people can come and live there for several days. And Frank's group actually measures many aspects of human physiology, behavior, even metabolism these days, 24 hours around the clock. So there are very few places like this, and I'm really glad that we can have a nice conversation about circadian rhythms in humans.
Likewise.
Yeah.
Sachin, yeah.
So to begin, how do you define circadian rhythms, both scientific and maybe for everybody else? How can you explain?
Yeah. So circadian rhythms really are describing those rhythms in biology and physiology that are driven by our what's often called our biological clock or our internal clock, which is really a combination of clocks. We have one major nucleus in the brain, the suprachiasmatic nucleus, as master clock. So you could say as the director of an orchestra, because we have all these other clocks throughout our body. And so together we refer to that system as the circadian system.
Yeah. And so that means clocks, like any clock, can actually tell us time, whether it's irrespective of whether it's a sunny day, cloudy day, or there is no light. So that's a very important definition, right?
Correct.
So that's what you do in your lab. So you isolate people and they have no connection with outside. And the body can still tell what time of the day or what time of the 24 hours it is.
Right. So what we do is we don't isolate them in a sense of social isolation. So they're in contact very frequently with all the staff and carefully cared after, but they're in a time-free environment. So we make sure that it's not just there is no clock on the wall or on the wrist, but also there are no temporal cues in those circadian studies, such as a variation in a light-dark cycle, no windows, no access to radio, TV, or any other sources.
No text?
No cell phones or text, imagine that.
No television?
Exactly. So all factors that we're so used to having access to all the time, we remove these time cues, and then we use specialized protocols to also dissociate, so separate the influence of our internal timing system, our biological clock, versus the influences of our behaviors and our environment.
Yeah. So this is very specialized lab, and one day maybe I can come and visit your lab.
you
I don't
should
want to volunteer because
You can come as a guest.
yes. So when we think about circadian rhythm, as you said, not all of us can go and live in such a lab and figure out what is our rhythm. Is there any biomarker or something that you measure to figure out what is the internal clock? How does it work?
Right. So that's absolutely right. So these studies that we do in the laboratory are quite intensive, both for the investigative team and the participants, expensive, quite, as you mentioned, restricted in the places in the world where you can do this. Luckily, there are other metrics one can use to get a handle on what is the timing of your internal body clock. And so the gold standard field-based measure for that is dim light melatonin onset, which really is describing the rise, the time at which melatonin, this night hormone as it's often referred to, is rising, which typically happens in the evening hours. And even if you and I, Sachin, keep the same sleep-wake cycle, our onset of melatonin may be quite different, may differ by 4 hours, say. And so it gives an insight into what's really happening in the brain that otherwise we couldn't access.
Yeah. So the reason why you do dim light is because even this regular light level that's in many living rooms or bedrooms or bathrooms, that's enough to suppress melatonin.
Right.
So it will kind of mask the internal timing. I see.
Well, it masks this measure of internal timing.
Yeah.
And so it used to be thought that, well, humans are not sensitive to light in for the circadian system regulation. Turns out that humans are quite sensitive, as you say. So just regular room light intensity is more than sufficient to very clearly and dramatically lower your melatonin levels, as well as it will influence the timing of your clock. So the two really kind of parallel effects light has. One is acute effects on the circadian system and its output, such as suppression of melatonin. Yeah. And the second is that it can also move your clock either later or earlier, depending on its time.
So is that the reason why many circadian biologists suggest that you should not go to a grocery store because the lights are so bright that can suppress your melatonin? Even 15, 20 minutes of bright light, is that enough?
Yeah, so it's interesting the point you make about warnings not to go to the grocery shop. I would say it depends on the time of day.
Yes, of course.
For that warning.
Yeah.
So that's just, and I'll make that point second. But to your point is that yes, even brief exposures to light can be quite impactful. Yeah. In fact, if you look at the sensitivity of the circadian system, for example, measured by melatonin suppression, you get most bang for your buck at the start of the light exposure.
I see.
So if you double it, it doesn't mean that your effect on the circadian system is doubled. So already brief exposures can be quite impactful. And then to that second point is that yes, if you would go to the grocery store really late in the night, just before you want to go to bed, I would say don't do that, because you'll be suppressing your melatonin, which is involved in part in facilitating the onset of sleep, as well as involved in many other physiological factors. Whereas I would recommend you getting exposed to bright lights, and I would say why not go outside if it's possible during the middle of the day, because that's actually a signal to the circadian system that helps keeps us entrained.
Yeah, so when we think about the evening light, means I think almost all of us were born after we had electricity, but actually in the long history of human life, 120,000 years or so, for most part, except 150 years, we are only exposed to candlelight or maybe firelight. So that's how our system is built, right?
Right.
So that means when you do this dim light melatonin onset assay, so these people are living in a environment where there is no timing cue and they have candlelight evening or something similar.
Right. So, and
How much light?
how much light? Yeah. So typically, one would say you'd need at least to keep it below about 5 or 10 lux. So
Yeah.
what is 1 lux? 1 lux is one candle at arm's length. That's the definition of a lux. Of course, wavelength matters, but more or less, that's a ballpark figure. So it's a low level that really allows the regulation of melatonin without it being what we call masked, so without it being overruled by this suppressive effect of light.
And then how do you, what do you actually collect? Plasma or blood or urine or skin?
Right. So the gold standard would be to measure it in blood. So and you can measure it in plasma or serum. The good thing about melatonin, it's very what's referred to as lipophilic. So with other words, it dissolves well in fats. Now your cell membranes are made up of a lipid layer of fat. And so the good thing about melatonin is it can easily penetrate and pass membrane barriers such as to your saliva. So you can easily also detect it in saliva, although at slightly lower concentrations. And that's actually what people also do. And so when applied to field-based studies, saliva is your friend. And so you can do it in urine, but you can't do a real dim light melatonin onset in urine in the sense that
be too many times.
Correct. So your sample resolution, meaning how often do you need to collect a sample across a time window for urine collection, is just too infrequent. And so typically what's recommended is every hour to have at least one sample. And to do this over a stretch of time of about 6 hours before your habitual bedtime, until your habitual bedtime, or ideally 1 hour later, you will be able to capture the dim light melatonin onset of virtually all healthy participants. We can talk more about people with circadian rhythm sleep disturbance.
But I guess what is important to point out for a lot of people, because I always get this question, how can I get my melatonin tested? It's not a home-based kit that just like a COVID test kit, you can just spit there and then...
Correct. Right. And it's even to such extent that even if you go to your physician and you ask, okay, I want to have my dim light melatonin onset measured, most physicians don't know how to do this. And even most sleep clinics don't know how to do this. So it's really dependent. Typically, academically associated sleep clinics may have the ability to help you do this. One downside is currently, at least, there is most insurances would not cover this.
Insurance actually cover? Some insurance cover?
Well, I say most don't, because I don't know of any example where they do.
It's whatever I have heard, it's mostly research.
It's either research, or sometimes if the participants are willing to do that, they can help support the financial aspect of that, or sometimes clinics have pots of money, typically research related. And so so there's unfortunately not a home kit. And even to this day, and we are working on a manuscript that we have submitted on giving globally and across the world guidance as to standardizing how dim light melatonin onsets should be determined.
So one thing that you said is, even between you and I, if we go to bed, say around 10 o'clock at night, then there is inter-individual variability. But on an average, like, is there a trend? Like, for example, can we say 50% of people may have dim light melatonin 2 hours, 3 hours, or 4 hours before?
Yeah. So if you look at the range of when it occurs, you capture in healthy, unmedicated individuals, you captured the dim light melatonin onsets occur approximately between 4 and 0 hours before bedtime. The average is probably about 1 or 2 hours or so before bedtime, and it depends also a little bit on how you define exactly that uprising slope. But that's in a few 1 or 2 hours before your bedtime, most people on average will experience that rise and will also feel the effects of this rise in the sense that they will become gradually more sleepy.
Yeah. So then that's why the kind of rule of thumb, of course, people are different, but the rule of thumb is to avoid bright light 1 to 2 hours before bedtime.
Right. I think that's a good ballpark. Yes.
Yeah. So now coming back to, so this is the dim light melatonin onset before habitual bedtime.
Yeah.
What happens for someone who is not using an alarm clock to wake up? Does melatonin begin to also drop to baseline before that person wakes up, or it takes few minutes?
Right. So typically, what you see, and what I'm going to describe is more a almost like perfectly entrained individual on average. What you see is that melatonin starts to already decline its concentration before somebody wakes up habitually. But that decline typically runs into after you've woken up. So typically, it's still there is some remaining elevation of melatonin.
So maybe an hour or two?
Yeah, so about an hour or so. The other aspect to that is that because most of us are exposed to light when we're awake, our profile of melatonin is somewhat compressed because in the evening it's artificially lowered by light exposure, whereas in the morning hours, light exposure will further make sure that the light that the melatonin production is kind of turned off.
Oh, I see. So the point is, if somebody is waking up and not exposed to bright light, so for example, somebody goes to the bathroom, but it's dim light, then it's likely that that person's melatonin would still take an hour. So
so if they
come down to
exactly. So if people would remain in dim light conditions after their habitual wake time, melatonin will come down anyway around 1 hour after waking up. Correct.
What about people who wake up to alarm clock? So for example, they're not getting sufficient sleep.
Yeah.
So even when the alarm clock goes, that time their melatonin is still at say 100%. And then it will take a little bit of time for them to go down. So so it'll be maybe just like we came up with a rule of thumb that 1 to 2 hours before bedtime there is melatonin increasing. Maybe for waking up, particularly those who are waking up with alarm. Maybe at least an hour.
I would say an hour. Yes, exactly. That's about what we see.
Yeah.
Correct.
So now, melatonin, how does it actually, does melatonin make us to sleep, or there are people without melatonin, they can also sleep?
Right. Melatonin is not needed to sleep.
I see.
So for example, we looked at this in a very small cohort of people with tetraplegia, or quadriplegia, also known as. So people who are paralyzed from the neck down, and if it's a full transection of the spinal cord, what happens is that because the projection from the central biological clock regulating production of melatonin in the pineal, both are in the brain, but it dips down through the spinal cord, and if that pathway is transected, those individuals do not make any melatonin. And so we've looked at the sleep by polysomnography, where we put electrodes on the scalp, and what we see is that those individuals still sleep. We have found, and again, this is a very small trial, that there's a slight reduction in the amount of sleep that they get if they're given the exact same 8-hour opportunity. So the sleep quality may be slightly impaired, but the effect of melatonin is relatively subtle. It's not like a sleep aid that we're accustomed to, where it can literally knock you out. And if you increase the dose too much, you can eventually enter into coma. That is not something that happens with melatonin. The idea is that as you increase melatonin's concentration, the receptors get saturated, and if you then further increase it, at least through the receptors, it does not have a further effect. So in that sense, melatonin is very different than a sleep aid, and melatonin is just one of the many factors that are regulating our sleep-wake cycle.
So you must have seen a lot of clinical data or the effect of melatonin in changing sleep structure. What does it actually change? Because when it comes to sleep problem, as I understand, there are three. We can put all sleep problems, those who can still go to sleep. I'm not talking about insomnia, but people who can get some sleep. 3 buckets. One, difficulty falling asleep.
Yep.
Second is fragmented sleep. They wake up too many times. And then third one is insufficient sleep.
Right.
So how melatonin actually helps from clinical stuff?
Yeah, that's a good question. So regarding the benefit of melatonin, let me start out by saying that in a healthy individual, where there are no apparent disturbances in melatonin production, melatonin at night is unlikely going to help that person. And it's because that person already is producing melatonin and typically already has a high sleep efficiency. So now let's take that healthy person and schedule them to sleep during the day.
Yeah.
Then melatonin will increase their ability to sleep. So they can still sleep without melatonin during the day, but as you may have experienced, that sleep quality may not be that good.
I see.
The trial I have the most direct relationship with, because I designed it and executed it, we study patients who were taking beta blockers for their high blood pressure. Now, what's interesting to note, and you might ask about how is melatonin regulated?
Yeah, exactly.
One of the factors that's important in melatonin regulation is the sympathetic nervous system innervation to the pineal gland, which is the organ that is responsible for the melatonin levels in our circulation. Not throughout our body, but in the circulation, it's really the pineal gland. So
it's at the top of the
top
of the head.
not in humans, it's not in the very top, but yes,
it's and the forehead.
It's quite kind of deep, deep in. But indeed, I think in let's say rodents, it's actually quite superficial near the skull. But so in those patients who had essential hypertension, so high blood pressure for a long time, were being treated with beta blockers. Beta blockers are known to suppress melatonin, so we wanted to see if we now supplement this with melatonin taken by mouth. And we did a double-blind study, meaning that we didn't know what they were receiving placebo, like this kind of what we refer to as a sugar pill, or there's no sugar in it. And what we found was that, to your question, that the biggest effect we saw in improving sleep was actually on the sleep onset latency. So how long does it take you to fall asleep?
I see.
So people fell asleep much faster without too much difference later down the sleep episode. So, but I would say it really depends on what patient population you are looking at, or in what condition you are as a healthy participant. Let's say you're traveling across time zones and you want to visit Paris and you want to have you want to improve your sleep. Most of the benefit, I think, in general, is on the onset of sleep. You can also talk about the structure, but that's the timing is most on the onset.
Yeah. And then there's this idea that when we pop a melatonin pill, nearly, I don't know exactly, 90, 70, 80%, good chunk of it is actually metabolized and cleared out by the kidney within 15, 30 minutes, something like that.
Yeah, so exactly. So the half-life is estimated to be in the order of 40 minutes, or a little bit longer than that. The main metabolist metabolism of melatonin happens in the liver, but you're right, is that a lot of it is then excreted, or at least its metabolic product is excreted in the urine.
Yeah.
So through the filtering of the kidney. And so indeed the concentrations of melatonin after you pop a pill quite rapidly decline. So if you measure it in the blood.
And the blood level, that's what is more important. Even if it's filtered out, it's in your urine and you're not going to pee, it's not going to make it.
It's not going to make a difference because it will be in your bladder. So the circulating levels in your blood is what your organs see. Yeah. So it's what your brain sees and what all the other organs see. Yeah.
But these days, there are, sometimes I get curious because people ask me, hey, I'm taking this slow release melatonin or sublingual melatonin that will just keep on dripping melatonin throughout the night or 4 or 5 hours. Has there been any study that you know of that whether it affects sleep structure? Because you said sleep latency.
Right.
But since half-life is 20 minutes,
right,
it's likely that if we keep melatonin dripping from this pill,
right,
will it improve?
Yeah. No, that's an excellent question. And indeed, so the fact that indeed the onset of sleep is most affected is likely due to that the melatonin concentration is certainly very high there. Having said that, in the studies that we have done, so we've given people 2.5 milligrams of melatonin. Yeah. It's something that you will buy over the counter in the United States at least.
But actually these days...
Or much higher.
5 milligrams is the...
Five is kind of the standard.
New normal.
Right. So this is even half of what you kind of typically find.
Yeah.
But then if we look at the... concentrations in the blood, we still see that after 8 hours, it's still at or above nighttime physiological concentration. So it's kind of coming down after about 9, on average, after about 9 or 10 hours, after just 2.5 milligrams.
So this is another important point. Like when our body is producing, pineal gland is producing melatonin, light will suppress that melatonin production.
Yeah.
And melatonin is cleared out. But when we pop a pill and there is light, that may not reduce. The light may not reduce that melatonin.
No. Right.
So this is very important because so we go back to the healthy person who saw somewhere somebody told him that melatonin is good for them and then took the pill, and that pill might stay beyond 7 hours of sleep. Because a lot of people, they come back, they say, well, I took melatonin, but the next day until noon, I was feeling sleepy and groggy. Is that the reason?
Yeah.
Partly means we cannot.
So I think one important aspect that I didn't mention is that I said average, I think, but the inter-individual difference in the metabolism of melatonin is actually quite large. So some individuals who may metabolize it slowly may have, like you say, levels elevated, let's say, until noon or so. And so that is quite likely a possibility why some people say, well, I actually don't feel more rested. Melatonin didn't help me, even if maybe they have naturally suppressed melatonin that you might want to supplement. And to go back to your question about extended release melatonin, which is a description of kind of having melatonin stay around longer because it's released in kind of slowly, is indeed one approach that people have taken, such that you don't give this very high concentration initially that then rapidly declines. You kind of try to emulate more natural nighttime variation. And just to comment, it's an interesting point you make about some people don't really report that their sleep subjectively feels better, even though we can measure that it has improved. It's quite different than what participants and certainly patients with, let's say, insomnia or sleep disturbances report after classical sleep aid. So they may report, I didn't remember to be awake. I must have slept well. And so they will subjectively report that their sleep was better, whereas if you measure their sleep actually may be disrupted.
And they may not remember that.
And they may not remember that.
I see.
So to make a slight comparison with the classic sleep aids.
Yeah. No, that's very interesting. And as you said, the inter-individual difference, I have experienced it because I think I'm I would say cheap date for melatonin.
Right.
Because even half a milligram is enough for me.
Yeah.
And then if I take a meg, then I am groggy the next day.
Right.
So these days it's really hard to get 1 meg, as you know.
Right, exactly. You need to get a cutter or a grinder.
Yeah, grinder or something. That's really interesting. But then to kind of so melatonin is one of the markers of circadian rhythm, but there are also other things. For example, body temperature changes.
Right.
Yeah.
So melatonin is what is often considered as a gold standard of assessing, having a window into the central clock. So having kind of hands on the clock to read out what's the internal clock in the brain, what's the time there. But and one of the reasons is that melatonin is not so strongly affected by what we eat or physical activity or body posture. There are some effects.
Yeah.
The main one is light. So as long as you keep light low, it's a very good marker of the onset of the biological night.
Yeah.
I would say the second strongest, well-known at least, marker would be cortisol.
Yes.
Which is typically for most people is known as the stress hormone. But really, if you look on a day-to-day level, what's really driving the variation in cortisol is not what stress events you have. It's the time of day you measure it at.
I see.
And so cortisol peaks right around your habitual wake time and rises starting kind of halfway through your night. Very predictably rises rapidly to a peak and then gradually declines over the rest of the 20 hours. And
so the peak is at wake-up time, habitual wake-up time, or 45 minutes or an hour after?
Yeah, well,
I always hear that.
Yeah, exactly. And this is true, Satchin, because if you measure cortisol during a regular sleep-wake cycle, your peak actually occurs slightly after you wake up.
Yeah.
But it's not because that's your circadian peak. It's because the transition of sleep to wake, and as we have shown, was actually my second paper in my career, as we have shown, light exposure in the morning can elevate further your cortisol.
Oh.
And so this is so the first aspect is also referred as the cortisol awakening response. The idea being that the transition from sleep to wake itself is a challenge to the body.
Yeah.
And the second is that light exposure acutely and phase dependently, so depending on the time of day, can further stimulate cortisol. And this is what results in, if you measure it in regular sleep-wake cycle conditions, is a peak that is slightly later than the wake time.
Yeah. But that's the peak, that's the maximum.
That's the maximum
throughout the day.
Right.
And unless somebody is super stressed or something happens later in the day on a regular day.
So it's an interesting anecdote to maybe mention here. So Charles Czeisler, who's the chief of the division of sleep and circadian disorders at Brigham, he very early in his career became interested into circadian rhythms because of analysis of cortisol in patients who were about to undergo cardiac surgery where their chest would be opened. So quite a dramatic situation. What he found was that the largest increase in cortisol he observed was not when the physician was explaining it, but when the nurse then subsequently came in to shave the chest, which made it very visceral and real. But next day they would be... And so, and why am I saying that? Well, because even under those very stressful circumstances, that cortisol peak was about as high as the morning peak, meaning that your circadian regulation of cortisol in your average day is really the dominating factor driving the variation.
Wow. Even the even the anticipation of an open heart surgery
Yes.
is not going to stress you as much as the morning peak.
Right. It's about the same.
Oh, wow. That's something that I never knew.
Right.
So there's a good story about Chuck.
Right, exactly. Yeah. And so that's why I say that would be kind of the second marker. You can measure it during a regular sleep-wake cycle. It will be influenced by other factors, certainly, but there is this dominating circadian effect.
Oh, I see.
The third measure that you mentioned is measuring body temperature, specifically core body temperature in the center of your body. The measure of core body temperature is a very useful tool in dedicated circadian protocols that we run. It's not as good if you measure it during a regular sleep-wake cycle. Mm-hmm. The reason is that the behaviors, including our rest activity cycle, our eating, our sleeping, our body posture, influences your core temperature. So if you measure from people every minute across a 24-hour day, you will see a variation, but only part of that will be due to the biological clock. And the other part is all due to all the behaviors.
I see. So it's not and that's core body temperature. And
that is core temperature.
If we do skin temperature, then it's even more noisy, I would suspect.
Right, exactly. So skin temperature is interesting. So core temperature, we all kind of know during the night, core temperature goes down. During wakefulness, core temperature is high. Skin temperature has the opposite rhythm. So skin temperature is high when you sleep and it's low during the day. And it's not just because you're exposed to more cold air during the day. It is because and there is a true circadian influence on skin temperature, where especially in anticipation to your sleep episode, skin temperature goes up, you dissipate more heat, so you lose more. Right, so you lose more of that energy. Of the temperature, and then subsequently your core temperature declines. So yes, skin temperature is a measure. It's relatively easy to assess it because one could build it in, and many devices will have it. But again, skin temperature, as you point out, it's more susceptible to noise. The major part of that is just the exposure to varying temperatures around your wrist, if that's where you're wearing it. Yeah.
So this is interesting. We discussed one night hormone that links to sleep, and then the stress hormone or cortisol that makes us awake. But circadian clock also regulates hunger, satiety. So are those hormones also circadian?
Yeah, that's an excellent question. So Stephen Scheer, my former mentor and longtime colleague and friend, had looked at this specific question for leptin, a well-known hormone for satiety. It's a hormone that is produced by fat tissue, white adipose tissue. Because if you measure leptin during a regular sleep-wake cycle in people, what you actually will find is the leptin will rise across the day. But it turns out it rises because we're eating during the day.
I see.
And it will decline throughout the night because we're fasting. So the majority of that is actually driven by the eating fasting cycle. But Steve has shown that there is a component of leptin that is under circadian control. But paradoxically, it's actually peaking in the biological morning, not in the biological evening.
I see.
So that just points out very clearly that the observation during a regular sleep-wake cycle of any outcome, any physiological or behavioral measure, we cannot then conclude, it's driven by the circadian system, because it may just be a consequence of what we do, what we eat, how we move, etc.
So that's a good point, that if leptin peaks in the morning, then biologically, we are not designed to feel hungry in the morning.
And this nicely links into another study that we did. I think we published this in 2015, where we looked at hunger and appetite that you were just mentioning. So the subjective reporting using a computerized, what's known as a visual analog scale. It's a difficult word to just say, okay, on a 100 millimeter or 10 centimeter line, put a little line to describe how hungry you are, for example. So
Yeah.
fully satiated versus very hungry on that extreme. And so we can look at many different appetites to have a more complex picture. But the bottom line is that when you look at the effect of the circadian system using a gold standard circadian protocol, what we found was exactly what you were just saying, is that the circadian regulation of hunger is at its minimum right around the time that people normally wake up. And so the question then
when it is maximum,
it's at about 8 p.m. if you translate it to clock time. And so this is interesting because on the one hand, this may come across as very paradoxical, because shouldn't you promote energy intake when you wake up because you've just been fasting? Shouldn't you go out and hunt for food, so to speak? And so the way to think about, or one way to think about it, and of course this is all speculation, is that it is actually a very helpful compensatory regulation to compensate for the homeostatic control of hunger and appetite. So, so during the wake episode, we eat our meals. We build up a positive energy balance because we're consuming less. We're eating more than we can consume. We're consuming more than we can burn during that time. So we're storing.
We're storing. So that's a positive balance.
It's a positive balance. Thank you. Yes, we're storing. And so the effect then, what it has, that the circadian system promotes hunger and appetite towards the end of our wake episode, would facilitate this storage of energy reserves, such that the extended overnight fast is then easier to sustain and also prevents you from waking up with hunger. But it may also be part of the reason why so many people do skip breakfast or if they have breakfast, they don't feel really hungry.
Yeah. Okay, so that's good to know that biologically we are designed to be less hungry, and actually it makes sense. With hunter-gatherers, if they're so hungry and they're getting a hunger headache, it'll be hard for them to go and hunt.
Right.
So it's an interesting design, how we are designed to feel less hungry the first few hours after waking up. I'm not saying the daytime, but first few hours.
Right. And just to clarify again, so this is the pure circadian component.
Yeah.
Because if you look at, so homeostatically, we can isolate these two. We do actually see that homeostatically the hunger rises. So it's more of a compensatory effect that prevents hunger from kind of becoming, like you say, in the way of normal functioning.
Yeah. I'll go check all these cameras to make sure that they're okay.
Yeah. Still running?
Yes. Let me check that one. Navigating through tripods.
Yeah.
Like
big footprint.
Yeah.
Was it?
This one was sleeping.
No, it was.
I knew that sleeps after a few minutes.
Yeah.
Okay, cool. So we have discussed now 3 major systems: melatonin, and then cortisol, and then our hunger system. But you are also part of this research that a few years ago, one of your colleagues, Richa Saxena, made this discovery that in genome-wide association study, that's kind of the gold standard connecting genes to physiology, that one of the risks for being obese, I guess the first study was obesity or diabetes.
It was really a diabetes
study.
Focus, yeah.
Diabetes focus, that one of the melatonin receptor mutation in that receptor was linked. But one of the so there are 2 or 3 receptors for melatonin?
There are 2 primary receptors in humans. So there's what's known as the MT1 and MT2, also known as MEL1B and MEL1A and MEL1B, which is the same kind of system. But yeah, so those two receptors are the dominating ones, and they're very sensitive to melatonin. So they are responsive to very low concentrations of melatonin. And so Richa Saxena, who's a professor at Massachusetts General Hospital, discovered in 2008, 2009, with the rest of her team, that this melatonin 1B receptor variant, so the genetic mutation in that gene, was associated with increased risk for having type 2 diabetes, as well as elevations in especially fasting glucose.
Oh, okay.
And that discovery really shook the diabetes field and really... Sorry?
Circadian field.
And the circadian field, because the circadian field, well, I emphasize the diabetes field because they're not easily shaken. So I think it really helped to put circadian biology on the map for diabetologists.
Okay.
Because up until that time, Joe Bass's work has been really important in the diabetes field. But up until that time, I would say that physicians or researchers in the diabetes field weren't taking circadian rhythms all that seriously. But now they had a real hard measure, as you say, discovered by these genome-wide association studies. So these large cohort trials, population trials, where one links a risk for disease or a phenotype to a genetic variant and addressing confounding variables on a genome-wide basis. So you need large populations to do so. And that really was the starting point of a flurry of research that followed. I was very lucky and delighted to meet Richa during that time. So in 2009, which was the same year that we just had published our circadian misalignment work, which very nicely gelled together, and we can talk about this later, where we really had a common interest. And so we have teamed up and we gradually built our collaboration, first a one-year pilot grant, and gradually building up to larger scale studies. And so and like you say, for the circadian field, this was very exciting as well, because we, often people think melatonin has beneficial effects. Most people think about sleep, but there are some other aspects as well. This was also highlighting the fact that melatonin may also be a molecule that can have detrimental effects, and we actually should be cautious with the effects of melatonin for our health.
So this melatonin receptor, to be clear, that the bona fide ligand is melatonin. Although the receptor has a mutation, one can argue that it may be sensing something else. But
yes. And that's a good point. And the other point to make there is that this variant, a single nucleotide polymorphism, was actually the causal variant. So it turned out that these SNPs act as like little flags, like, okay, there's a change in this area. Turned out that particular single location on the DNA was the causal variant. And then thirdly, just to make the point that we're not talking about a rare variant. We're talking about a very prevalent variant. So the initial studies were looking at the how many percentage of the population has this particular variant. Initially looking at Caucasian population, finding that the minor allele frequency is about 30%, meaning if you take together homozygous and heterozygous individuals, it's about 51% of the population. So it means that this is not some obscure, rare occurrence. This is affecting about half
About
of
half of
people.
the population
Yeah.
have this mutation. So then the next big breakthrough was how this was linked. Means, can you explain how
Yeah.
the melatonin means?
Right.
We thought that melatonin receptor present only in the brain, maybe mediating sleep, but
Right.
is it found elsewhere? What is the story?
Yes. So I think the original story very early in that after the GWAS was I think really an important observation when looking at the pancreas and specifically pancreatic beta cells, which is this organ in the body that is responsible for producing and releasing insulin, where insulin is important in glucose control and diabetes risk because insulin helps bring down glucose, so blood, sugar in the blood, bring it down to lower levels after eating a meal.
Yeah.
And so if that release of insulin is not happening well, so there's not enough release, then the glucose will stay high in the blood, which is a risk factor and a diagnostic measure for diabetes. So the fact that melatonin receptor was present in the pancreas, but then secondly, most importantly, that the variant suggested that there is an overexpression of the melatonin receptor on the pancreas. So then the model was, and I think to this day still is, but it's a little complicated, but I'll skip over the complicated parts, is that the glucose acts on the pancreas, suppressing insulin release. But in the people who have the risk variant, there is more melatonin, so there's more suppression of insulin.
So not glucose, the melatonin.
Oh, I'm sorry. Let me rephrase. Okay. So the melatonin binding on the receptors in the pancreas then suppress the release of insulin.
Yes.
When the pancreas is stimulated by elevated glucose levels. And so in people who are carriers of the risk variant and they express more of this receptor, that the suppression of insulin would be amplified.
Yeah.
And so they would be less able to cope with a glycemic load, so with a sugar-rich
because they're producing less insulin.
Because they're producing less insulin. Now this is one side of the story, and this is the most convincing evidence there is, but there is also evidence that there are effects that are not just through the pancreatic beta cell. So an indication that there are also effects on the sensitivity to insulin, so insulin sensitivity.
But that's kind of the dominant hypothesis. There are many 3 or 4 papers that came out.
Right, exactly. Yeah. And then a third idea would be that it's maybe even acting on the central clock.
I see.
Where there are melatonin receptors, and so maybe there are influences there. So the dominant hypothesis is really focused on the pancreas, but there are observations that are not fully explained by that. Yeah.
So now let's go back to this melatonin and diabetes. So since melatonin levels begin to rise for average person 1 to 2 hours before going to bed, so that means even for anyone who doesn't, for the 50% who have the normal melatonin receptor, even for them, is it a bad idea to just eat before bedtime because that melatonin will inhibit insulin production?
That's what we see. So, well, we don't.
But I guess your lab actually did that experiment.
Right, exactly. That's what I'm gonna. So we did 2 type of. But let's focus on the timing of the late meal. Let's call it the dinner.
Late.
So the study we did, and this was Richa Saxena and Marta Garoulet, who's a professor at Murcia University, and colleagues. We and this was really a study that was run at the site of Professor Garoulet, and so she and her team, what we designed is we scheduled the high glycemic load to be either 4 hours before habitual bedtime or 1 hour before bedtime.
So that means a big dinner equivalent.
Yes, let's call it the big dinner
Dinner
equivalent.
equivalent,
Exactly.
yeah.
And we had the same fasting duration before it. So to standardize that.
Yeah.
And so when we moved the meal later, it was in the same individuals, it was a randomized crossover trial, we find that glucose tolerance was decreased. What does that mean? It means that after the same exposure, glucose levels rose much higher when the meal was scheduled late.
It's in the same individual.
In the same individual. So it's
that's very important.
It's very important.
Yeah.
And so what it means is that that was for the group as a whole.
Yeah.
To your question, in the people who were not carriers of the risk parent, this also happened.
Yeah.
But this effect was much larger in people who were carriers of the risk parent, especially in those individuals who had two copies of this allele.
Ah.
So it appears to be a dose-response relationship for the number of copies you carry, how sensitive you are to a late dinner equivalent. Now, we think that certainly the effect of the genotype, that would be because of its role in signaling of melatonin, because it's regulating the melatonin receptor. But we don't know, even in the absence of melatonin, the circadian system had other mechanisms by which it can regulate physiology. So we're not saying that melatonin is the only factor involved, but it's the key factor involved in the genotype dependent change.
But at the same time, there is also some literature that insulin production itself slows down late into the night.
Right.
So even if you take melatonin out of the equation, the pancreas still goes to sleep.
Right. Right.
So then, if we take all this knowledge that pancreas has a clock that reduces, that makes it less efficient to produce insulin because it's going to sleep, for example. And then on top of that, melatonin, which begins to rise, say, 2 to 3 hours before bedtime, that can, again, there's a second strike on pancreas that if you eat close to bedtime, that might happen. And then the third one, for people who have this variant, which is almost half of the population,
right,
it's even worse. But it's really hard for anyone. Means I don't know whether I'm wild type or
right
too. But it will be safe to say that for most people, it will be okay if they avoid large meal or big dinner, say 2 to 3 hours.
Yes,
within 2 to 3 hours.
Yes,
habitual bedtime.
I agree. I think that's a safe conclusion to draw. That for most people, and I would. So I think for
I guess going back to your clinical trial,
right?
Those who did not have the mutation, they still showed impaired glucose tolerance.
Correct.
When they ate glucose.
Correct. Yes, exactly. So for most people, variant or not, this would be a moment in time that your body can't cope as well with a glucose load. And so, and I like the point you make is that part of this is melatonin, part of this is mediated through the interaction with the genotype, and part of it's independent of it. For example, you mentioned the difference in pancreatic beta cell function dependent on the time of day. We've looked at pancreatic beta cell function at, let's say, 8 a.m. and 8 p.m. equivalent circadian phase. And we've found that regardless of your eating fasting cycle and your sleep-wake and rest activity cycle, that your pancreatic beta cell function is dramatically stronger in the biological morning compared to the biological evening.
Yeah.
And we think that that is not, so during those assessments, melatonin was low. So at least acutely, melatonin was not at play there.
Yeah.
So I think it's an important point again to make is that melatonin is there an important player, but it's not the only player.
Yeah.
Yeah.
So then it also has implication on people who take melatonin supplementation,
Right.
or particularly when we have jet lag and we're trying to adjust to Paris
Right.
time, that we have to be careful. So then I guess it might be ideal that you have an early dinner, give yourself at least 1 to 2 hours, and then have your melatonin
Right.
pill, because the initial glucose response after meal can last 90 minutes to almost 2 hours for some
Yes.
people.
Right. Exactly. Yeah.
Yeah.
No, and that's also something we have directly studied. And
Yeah.
so again, with Marta and Richa, we looked at the dosing of a pharmacological intake, which really means that when you pop a pill, as you say, because of the relatively large concentration you're taking, the melatonin concentrations rise transiently much higher, often 10, 100-fold higher than even peak nighttime levels.
Wow. Even
And so-
100 times higher than our biological peak. Right?
Correct.
Wow.
So really large, and these are concentrations achieved by melatonin of about 5 milligrams
Yeah.
or 2.5 milligrams or so. So something that can easily be bought over the counter.
Yeah.
And so, so the question therefore was, well, actually, I should say, the first study we did was actually using a pill, looking at pharmacological. Our later study that we just discussed about dinner timing was our second question. So the two studies separately, what they show is that both pharmacological, so very high levels,
Yeah.
and physiological levels, so occurring every night in
Yeah.
all of us, both of them impair glucose tolerance, and both of them interact with the genotype, the MTNO1B SNP. And as you say, yes, I think that it's safe to say that if you wait at least, I would say, 2 hours after eating an evening meal
Yeah.
before you would take melatonin supplementation is wise for, I would say, everybody.
Yeah. And at least after melatonin supplementation, even a small bedtime snack, because
Right.
a snack can have 10 grams of sugar sometimes,
Right,
and 10 grams of
exactly.
sugar can actually spike a lot of sugar, blood sugar
Right.
level.
Exactly.
So, yeah, I mean, this is something very practical. And means after I saw all your papers, I'm so scared to take melatonin. Not scared. I mean, I always, as I said, I barely take 1 milligram. It's so hard to get even 1 milligram. You go to kind of twice and then do that.
Well,
And then you know that, okay, so after you take your melatonin, the kitchen is closed.
Right.
The only thing.
And I think and I think what's helpful is that as we understand more about the dynamics of this and the inter-individual differences, it helps one to better schedule and coordinate when to take melatonin, when to eat.
Yeah.
So the more you realize, hopefully it doesn't make you scared. It makes you more informed and can improve your health.
Yeah. I mean, scared means, so that's a wrong word. I'm more careful. I'm always thinking, okay, have I had my dinner? Am I again going to eat, or am I going to see a friend?
And I know you're very aware of all this. So, thinking about light exposure, exercise. So,
Yeah. So, do we have time? How is
I'm fine. If you want to,
because the circadian misalignment.
Yes, we can touch on that. Yes.
Yeah. Okay, so another big topic that in circadian rhythm field, we always use this term circadian misalignment.
Right.
And can you just explain what is that misalignment? Because most people think that it's only the night shift workers whose circadian rhythm is misaligned with the day-night cycle. But actually, it's very different. That's part of the story.
Right. So circadian misalignment in simple terms, really means mistiming of behaviors relative to our internal body clock. And so,
Or the behaviors that affect our clock, or behaviors that are controlled by the clock. So, for example, eating.
right, good, yeah. So when I say behaviors, I really mean all the behaviors that typically have a 24-hour cycle. So typically, we sleep at night, we are awake during the day. We eat during the day, but we fast at night. We are typically physically active during the day. We are inactive during the sleep episode physically. And similarly for environment. So we're typically exposed to light during the day and darkness during the night. So that is the ideal condition. The example you gave, and which is easiest to explain, is a night shift worker.
Yeah.
So what does a night shift worker do? Well, a night shift worker does everything we do except shifted by many hours. So it's almost like an inversion of their sleep-wake, their eating fasting, their rest activity cycle, and often their light exposure is also perturbed because they will have light at night to different degrees. And you may think that that is fine because, oh, for sure, the central clock, the biological system, will rapidly adapt to that. And the unfortunate news is that that's not the case. The circadian system doesn't quickly adapt to night work. And in fact, and you may have heard this approximation, it takes about 1 day of adaptation to a new time zone for every hour difference in the time zone compared to where you came from. So let's say you travel from Boston to Amsterdam, you have to move your clock, your biological clock, 6 hours earlier. It will take you about 6 days if you're lucky. So, and that concept of the sluggish nature of the circadian system to change to a new behavioral cycle is the crux of the problem in shift workers. So they, by the time they show any adaptation, they would revert back to being awake during the day and sleeping at night.
Yeah.
Because many shift workers still want to have a regular life on their days off and want to be with friends and family. And the other factor is that even many shift workers don't even shift their clock when they do night work, because in the morning hours after their long night shift, they travel home by car, by public transportation. They're exposed to daylight. And as we just discussed, even relatively short daylight can have a big impact on the circadian system.
And they cannot avoid that because
And they cannot avoid that.
Even with these sunglasses, there is enough light
Right.
going through the sunglass, and that's enough to reset the clock.
Right.
Tell them that this is morning.
Right, because the outdoor light is relatively so bright. So on an overcast day, it's easily 10,000 lux or so. So yes, that is a problem. So what we're now faced with is a population whose central clock, or their biological clock, is not adapted, but their behaviors are completely out of whack. And so that mistiming is what we refer to as misalignment. Now, the point you made was that this is not just observed in night workers. And so one of the most common and easiest to understand examples, I think, is this concept of social jet lag, which means that, or which is defined as the difference in the timing of sleep during weekend days or days off compared to work or school days. And that's because most people, when they have a free day, they will sleep in later in the morning, they will go to bed later in the evening, and but then Monday morning comes around, and then all of a sudden they have to shift back all the hours that they may have been delayed in the weekend.
So I guess it'll be interesting to go back to your comment that it takes an average of 1 day to shift by 1 hour.
Mm-hmm.
So that means if I stay awake for 3 hours extra on Friday night, then for the next 3 days, my clock is out of sync because it's trying to catch up, or is somehow confused.
Yeah.
Is that good to say?
Yeah. So
Or maybe if I go night out on Friday 3 hours and then Saturday also again 2 hours or something, then my
it adds
clock is
up.
yeah.
Yeah. So exactly. So I mean, the reality is more complex.
Yeah.
Depends on many factors that we don't need, or we can go into. But so the bottom line is that, yes, as you said, that many people on Friday night they already start
Yeah.
a delayed bedtime. On the Saturday morning they have a delayed wake time, but then they repeat this from Saturday on Sunday again.
Yeah.
And then there are still people who on Sunday night like to sustain that. And so really what they have is a crunched, shortened sleep episode with a very early wake time relative to their internal circadian system that has gradually over the weekend drifted later and later. And so this is maybe not as dramatic of a exposure, but it affects so many more people than shift work does. And even if you look at permanent night workers, this affects about 15% or so of the working population. But if you think about social jet lag that we just discussed, this affects almost everybody to some degree.
I mean, I was actually looking up what is the definition of a shift work, because night shift work is very clear.
Even that is not that clear, but yes.
I mean, yes, means in our mind, okay, so somebody who goes to work and then means maybe stays up past midnight, 1 o'clock, 2 o'clock. We kind of have a visual picture that this night shift worker goes, and when everybody is going to work, this person is coming back home.
Right.
But actually, I was looking up this shift work definition in International Labour Organization, and they actually don't have one, but then the various European countries, they have come up with their own.
Yes.
And usually it's kind of a little vague because it says you have to stay awake and be engaged in some work for 2 or 3 hours at least between 10 p.m. and 5 a.m.
And that's the problem. There is no consensus definition of shift work. And so in some definitions, shift work is as broad as non-classical 9 to 5 type job.
Yeah.
And so what it means is that the estimation of the number or the percentage of people engaged in shift work dramatically differs depending on who you ask, because the definitions are not the same. So with night work, it's, as you said, it's more clear. There is some understanding that there are a substantial number of hours that are occurring between, let's say, midnight and 4 a.m. or so. That's a kind of the minimum definition. But even there, the definitions widely vary. So those estimates of percentages should be taken in that context. And that's also, if you see different percentage estimates, it's primarily because of the definition used. So using the definition makes, but it's well understood that if and one I think easier way to think about it for an individual level, if you are working during a couple of hours during the time that you would normally be sleeping, then this would be to some degree interfering with your organization or circadian organization.
Because when you're working, you're also exposed to light. Nobody is working under dim light.
Right. And so I think that's a very important point. So when you are thinking about misalignment of behaviors and environment, the other complexity is that there's not just one factor you're talking about. You're talking about a whole array of factors. You're talking about mistimed light. You're talking about mistimed sleep. In the case when you're working, you can't sleep, most jobs, without getting fired. The other is meal timing. And then there's physical activity. So, and those are really the big four. So light, sleep, food timing, and physical activity. And so I think what's really exciting in this symposium we're at now is the recognition, starting by the field, to take into account not just one of these factors, but consider them all.
So in that way, if we think about now, all people outside card-carrying shift workers.
Mhm.
I would say almost all high school students in the US and all college students experience the lifestyle of a shift worker, or they're having social jet lag.
Yeah, many, I would say many do. Yeah, certainly, I think.
Means you have studied Harvard students a lot. I don't think they go to bed before midnight, do they? Or the ones that drop out of Harvard.
Well, it's interesting, and I haven't studied them that much, but I know enough about their sleep-wake cycles. So it's true that, and one interesting thing is that, as with many of these factors, but especially here, there are very large inter-individual differences. So
Yeah.
you just see certain students are very organized and systematic and regular in their at least sleep-wake cycle behavior. Then there are students who are regular but have short sleep.
Mhm.
Then there are students who have highly irregular sleep-wake timing, but are somehow able to, get the hours in. And then, of course, the worst group is those students who are all over the place and hardly find time to sleep.
Yeah.
So
I guess it's Horacio de la Iglesia who did all these college students in UW, University of Washington. I was a co-author on that paper, and I guess he had collected almost 200 students' sleep diary and all
Yeah,
that. And it was interesting that maybe out of 200, 2 or 3 students, they actually went to bed before midnight during the weekdays.
right, right. Yeah, and then also I think needs to be put in context of when are they forced to wake up because of their
Before their first class.
requirements before their first class. Exactly. So yeah, so Beth Glerman and Andrew
Yeah.
McHale and Chuck Seisler have looked at this in Harvard students a lot, and
Yeah.
so those profiles are very consistent in that way of Horacio's work. So yes, I think it's important to point out because it's a vulnerable population in a developmental phase of their lives, critical. And the other, I think, important point to make is that at least it correlates.
Mhm.
We can't really say about causation, but it correlates with performance as well in school.
Mhm.
So, and this speaks to Harvard students. So if there's one way to motivate them to pay more attention to regularity and duration of sleep, that's one way to get them motivated.
Yeah. So now going back to this circadian misalignment, for most people, when they're staying up a couple of extra hours in the weekend and they're combining everything, getting light exposure because no one is sitting in darkness and
Right.
socializing. There is food, of course.
Yeah.
And sleep deprivation because they reduce or delay this sleep time. They may be waking up late. And there'll be a little bit of modest physical activity, or even if there is no physical activity, still these 3 out of 4 major factors will misalign.
Yeah.
So now we have talked about how melatonin is affecting metabolism in the evening, and now let's combine what is actually happening on those days. And I think you have also done the studies where you have looked at people who eat late into the night. They have physiological problems. What are those problems? Starting from, means we eat because we're hungry. Second, after we eat, sometimes we have control, our satiety hormone may kick in and we'll stop. But for some cases, satiety hormone may not kick in correctly and we may eat more, and then the digestion and other stuff. So what happens when people actually eat late?
So the most extensively what we have studied is really what one could consider as maximal misalignment. So what we've done is we have looked at individuals as they're in control under both optimally aligned and maximally misaligned conditions. What do I mean with that? Optimally aligned would be somebody who maintains a fixed sleep-wake cycle for a couple of weeks. We bring them in the lab, we maintain them at that same sleep-wake cycle. We have their meals regularized, we have their light exposure regularized. So they're in what one could consider as a very regular optimal phase alignment. And then what we have done is we either gradually or all of a sudden shift all these factors around. So we shift the meal timing around, the sleep timing, keep physical activity low in our in-lab studies. And then either if we move the light-dark cycle around, or we keep them in dim light. But then regardless of if we flip the light-dark cycle or we keep them in dim light, in both conditions we kind of see the same observation. So the summary of what we see happening following this experimentally, carefully controlled circadian misalignment is all bad news. It's impairment of glucose tolerance, so a inability of the body to cope with sugar in the blood, so it stays around longer, it rises to higher levels after an identical meal. We see increases in inflammatory markers, such as C-reactive protein or IL-6 or interleukin-6 across the 24 hours. So it's not just a single measure, it's across the board. We see increases in blood pressure, which we measure every half hour. So we have very careful assessments of that. We see also changes in the microbiota structure. So the microbiota in the oral cavity, so from saliva, you may wonder, well, wouldn't it be better to measure it in the gut? But the benefit of saliva is that you can have frequent sampling that you cannot do without getting invasive from the gut. The other thing is that the gut assessments that you could do without getting too technical are really how do you say this? A averaging over a long time as the stool is built up, whereas the saliva is refreshed at a very high rate. Regardless, we find some clear differences in that, and we also find not just effects on physiology but also on mood. So if we have a construct on anxiety-like or depressive-like mood, we see, and we repeatedly assess that across the wake episode, we see that their mood worsens as well. The good news is that for the measures we have looked at so far, we have an approach to improve that, which is a paper that Sarah Shalapa has been driving that we can talk about if you wish.
So how can we improve them? Because a lot of people, they have many barriers. So that's why they are forced to eat late at night. Somebody who has long commute, or, many young parents, they are they're driving their kids around for the after school program, and then by the time they have time for themselves or to cook, it's late at night. So it happens to millions of households. So what can they do?
Yeah, and
it's not an advice, but at least from your experience, what you have seen.
So we have a good idea of what theoretically can be done and what practically works in a laboratory setting. So I'll first describe that, and then we can talk about potential translation. So what we have found during this circadian misalignment approach is that when we misalign the behaviors and we observe these negative effects, let's call them negative effects, on all these outcome measures, that when we look at the influence that this mistimed sleep, for example, has on the sleep quality, is not what can explain our observations. And so what it suggests is that, yes, sleep is impacted. Sleep is not quite as good as when you sleep at night, but it's not that dramatically impacted. And if we analyze the contribution of that sleep, statistically, it's not the only driver. There is something else. And so one could then ask, okay, what mistimed behavior might then be important? And so one of the factors that relate to a lot of other work we've been doing is the notion that timing of food intake matters. So it's not just important what you eat, but also when you eat. So we've now combined those two insights of circadian misalignment effects, the effect of food timing, to build a protocol to test whether if we now correct the timing of food relative to the central clock, master clock, if that can help either prevent or minimize some of these adverse effects. The bottom line is that, yes, if we realign the eating fasting cycle with the central clock, even though the sleep-wake cycle is misaligned, we can prevent the impairment of glucose tolerance, which is of relevance to type 2 diabetes. We can prevent something known as internal misalignment. So where we see in a misalignment protocol that circadian rhythms, internal body clock rhythms, are no longer normally orchestrated, we can correct that. And we see that the mood impairment effects normalize. So at least on these three measures, and we're still analyzing all the other data, we are hopeful and we are very, very excited that this is a potential implementation where food timing might be an effective countermeasure against these adverse effects.
So that means if you're going out with your friends over the weekend, it's good to aim for the happy hour because
it's relatively early.
Relatively early, food is cheap.
Yes.
Yes. And then you can go for a movie or something without popcorn and soda.
Right. In a relatively dim movie theater is what you're saying.
Yeah, sparkling water.
Sparkling water.
And you can tell your friends that you're drinking gin and tonic, but who is checking?
Right.
No, actually, this is something that some people do. They go to parties and then they'll be walking around with sparkling water. People with a tiny bit of lemon and lime. It looks like you are drinking an alcoholic drink.
Exactly. And don't go to the late movie.
Yes. No, this is very important in this sense. Now, coming back to meal timing, and since many people try to practice time-restricted eating or intermittent fasting, and they find it's easy to skip their breakfast, and then to go from, say, noon or 2 o'clock, and then they say, okay, we can eat till 9 or 10.
Right.
And then, of course, these people also go to bed around 11. So that may not be the right strategy. Maybe if they move that window to earlier so that the last meal is happening 3 to 4 hours before bedtime, because these days most people are going to bed, say 10 or 11, or some people even 12, because if they have to misalign and then catch up with homework, or then that would be ideal. So it would be interesting to do that with maybe evening shift workers, because night shift will be a little bit challenging, but the evening shift workers who are going to work till, say, midnight or something, and then they're coming back home. Is that your plan to do something like that?
Yeah, so in fact we're actually going to the night shift worker approach. So we're just now starting up a trial to test the feasibility aspect. So can we really translate this eating pattern into something that's doable for a simulated night work condition? And so the reason for that is that the study that Sarah just published in Science Advances is really a proof of principle study, because the way we were able to solve this problem of normalizing eating timing while still having missed time sleep required a protocol that's not like anything that people do in shift work. So we're moving it now towards a solution that hopefully could be implemented in real life shift workers. I think in the case of evening workers, as you say, who may go to bed not all that late, I think the solution might be easier. I think so. we're trying to crack the hardest one
Okay,
first.
yeah.
Once we sort that out, I think we should have a good
Yeah.
handle on how to sort out the rest.
Yeah. No, but I guess for regular folks like you and me, it's
Mm-hmm.
there are many
Oh,
take-home
yes.
messages starting from melatonin and then when we should be eating our dinner,
Yeah.
or if there is pressure to go out for dinner late at night, what to do.
Right.
All of this are
Yes.
extremely useful for
Yes.
millions.
Right, exactly. And I think that, I mean, the social aspect that you bring up, I think is very important. So one needs to think about how can we find something that is moving in the right direction while still giving people freedom um, to have a social life, and at the same time keep in mind the behavioral changes that they can implement. The other aspect, I think, related to that sometimes friction between what would be ideal to do versus what socially
Yeah.
social pressures are or desires are, would be the concept of having like a break day in a week or so,
Yeah.
like a cheat day, if you like,
Yeah.
where people are given somewhat more freedom,
Yeah.
which will allow them to be more strict than the other days.
Yeah.
Yeah.
But I guess again, this social, we are tackling two issues that affect most people. Social aspect, which is also linked to cultural aspect, because it's not,
Yeah.
for example, back in India, the typical dinner time is not before 9 p.m.
And what time do people typically go to bed?
They actually eat dinner and then go to bed. So
Really? Okay.
10 or 11. And then, India is becoming the epicenter of diabetes, and obesity also is rapidly rising. Even in Spain, for example, Spain is now the country with the second largest concentration of obese or diabetic patients. I was surprised to hear that. I'm not sure whether that's correct or not.
I'm surprised to hear that as well.
I'm surprised to hear. Somebody, actually, a Spaniard told me that. So
Okay, we
I'm
should
going to
check
go back and check.
We should check.
Yeah,
Okay.
because it's we should not say something. That's it. But the point is, there is this social aspect, and then there is work aspect, because as you said, although 13 to 15% of the work force in Western countries are night shift worker, but still there are many morning shift workers,
Yes, absolutely.
evening shift workers, and then the gig workers are not even classified anymore.
Yeah.
Like
right.
the Uber driver who will pick
Right.
me up tomorrow
Exactly.
at 4:30
Yeah.
is not a card carrying shift worker.
Right. Exactly.
So in that way, as you said, a vast majority of us, maybe 70 to 80% of us, experience the lifestyle of a shift worker or even social jet lag kind of shift worker for at least few years in our life, we can say. So this all point to one thing, that is, we built this anthropogenic world, culture, our work culture and everything without the knowledge of circadian rhythm.
Mm-hmm.
So it's kind of, I said this is the late and asbestos moment, because we did not know what is the bad effect of late night eating. We did not know what is the impact of bright light, or even the point that you brought up, that even late night eating can exacerbate or will not help people who have depression or anxiety kind of symptoms. And we know a good chunk of people will actually experience depression or anxiety in their lifetime. At any given time, it may be 5 or 6%, but then 12 lives. So I guess this is this may take a generation to figure out public policy, individual awareness, cultural awareness, and then inside the family also. So I hope that discussions like this will percolate and will also influence maybe physicians, caregivers, to pay attention to simple thing, as you said, 4 major factors:
Right.
sleep, light, food, and activity.
Exactly.
Yeah.
Yeah. Yeah. So and it's so interesting because I think sleep by itself has kind of has undergone and is still undergoing this evolution of awareness, raising awareness among physicians, among the general public, and policy. And I think that the broader aspect that we just discussed today about all the other timings, so the timing of light, sleep itself, activity, and eating, uh, are earlier in that trajectory of change. And so, yes, I think that these type of conversations, hopefully, as well as many other activities, will help move the needle. But I think the time we're in from my perspective, we're in a relatively good time where people are are starting to pay attention to this change.
Well, I guess your means Harvard, particularly and specifically Chuck Seisler, his work on sleep actually helped to change policy for physician residents.
Yes, and it's not been an easy road, and still not.
It is still not, because even in some medical schools, I'll not name them, I have seen that different departments have very different schedule for the resident.
Correct.
But your point about late night eating and mental health just rang a bell, because we know that a significant proportion, I'm not going to say exactly what percentage, but I guess it's more than 20 or 30% of residents, physicians, PhD students also go through this burnout and depression. And in fact, nowadays people are reporting that maybe good chunk of undergrad students are also going through depression. And we know that all of them have one thing in common, that we all, means when I was a grad student, I had no idea about this meal timing. So I went through late night eating. I was overweight and obese. Means I can't say whether I was depressed or not, but at least I have seen many of my classmates, peers actually struggle with it. So I guess this is one interesting aspect, even for starting from physicians, grad students, and students who report a disproportionately high incidence of depression and anxiety. This can be one way to address them.
Yeah, and I think it's one way that should be doable, an intervention like that. So the work hours, so the sleep, shifting the sleep timing, that's almost impossible to address. One can address when the sleep is occurring, during the daytime, and to make it as good as possible, ruling out disruptors, etc. But still, the sleep will be displaced. But that's not necessarily true for food timing. One can cope with changes in eating pattern to limit certainly high glycemic and high carbohydrate intake during the night. So I think it's a practical solution that could be married with still having the night work that will not go away anytime soon. Okay. Very good. Well, thank you.
Thank you, Frank. Thank you.
Thank you.
Yeah. This was wonderful. Thanks again for listening to this episode of Performance Around the Clock. I'm your host, Professor Satchin Panda. I hope you learned something new and found this episode exciting. If you did so, please leave us a comment. If you like the science that we discussed and would like to make a donation to research in my lab at the Salk Institute, you can do so by going to panda.salk.edu/giving. Thank you again for listening, and I'll see you next time.